Again, thank you all for being here. Excuse me. Thank you all for being here. And today we're going to talk about sequence of operations. That's kind of a fancy terms for just inputs, outputs, and how they relate to each other. Um, Another place you'll see the term sequence of operations is on all of our fire alarm drawings. We have a table that says sequence of operations, and it's a written narrative. When this happens, this other thing has to occur. And it's kind of just a generic description of what we're going to go over here today. So before we get too deep into it, I want to talk about three common terms. We've talked about them before, and they're ones you'll hear a lot. I find it's important to have a really clear understanding of these just for owner trainings. It's when owners seem to get confused or say the wrong thing a lot of times. So first we have the alarm. This is the one that fire alarm is famous for. It's all the blaring sounds and bright lights and everything telling you to get out of the building. This is also the one that calls the fire department as well as the end user, the customer, the owner of the building, whoever. That's the alarm. It means there's some kind of smoke or water flowing, or someone pulled a pull station, or something went off that's saying, hey, there's a fire in the building. Trouble and supervisory are both very similar, except that trouble is monitoring the fire alarm system itself for problems, and supervisory is when we're tying to other systems to monitor them for problems. So when we have missing devices, open circuits, batteries going down, things like that, those are going to be troubles. When a sprinkler pump loses power, that's going to be a supervisory. When a sprinkler valve isn't in the right position, that's a supervisory. When there is smoke detected in an air conditioning unit, that's a supervisory. Those are all problems with systems. They're just not our systems. Other than that, trouble and supervisory basically do the same thing. They put a description of whatever's wrong on the panel, and they send that signal to monitoring, who communicates it to the end user, but not to the fire department. So I just want to make sure everyone's real clear on what those three signals are, because I'll be mentioning them several times as we go. And then something else we're going to need to talk about is there's two types of evacuation methods. The most common one we see is general alarm. This is for every single building except high rises. So whether it's a school or a little lease space, warehouses, whatever, they all, when the entire building evacuates at once, that's general alarm. Low rises and mid rises are also general alarm. High rises do what's called a 3-floor evacuation, and that's where you'll have the floor that the alarm or the event happened on. That goes into alarm to evacuate. The floor above it evacuates, and the floor below it evacuates, but none of the other floors will. This has a lot to do with stairwell capacities and how big the building is, and making sure that it's going to actually be able to evacuate, and there's not like some kind of traffic jam that prevents evacuation. Also, it kind of helps stay one step ahead of everything, just because, if you have the floor that the event's on, and then both floors on either side of it are evacuating, and then say the fire spreads, that evacuation is going to continue to stay a floor ahead of where the event is. So just real quick, there's general alarm and there's 3-floor. And we're going to talk some of these sequence of operations are specific to high rises. So I threw that 3-floor in there because that's also specific to high rises. So then we have our common inputs that we talked about. We have pull stations, which are alarms. Smoke detectors cause alarm. Elevator lobby devices, these are also smoke detectors, but they have some specific operations they do, so I listed them separately. Those are alarms. Duct smoke detectors, it's physically the same smoke detector head that's put in a housing specific for duct smokes, but those we programmed those to come into the panel of supervisories, except in the city of Pearland. The city of Pearland Fire Marshal's office wants those to still be alarms, but other than Pearland, they're all supervisories. Sprinkler systems, I have listed 2 separate lines. They can be supervisories or alarms, depending on if you're talking about the valve or the water flow device. And then IDC circuits. We've gone into those in pretty good detail. Those can be conventional devices. Those can be your sprinkler monitoring, your kitchen hoods, all those kind of things. So I didn't say supervisory alarm because that just depends on what the IDC circuit is supervising. Next, we have the outputs. So I put strobes and horn strobes together because we don't control those separately. The horn is powered by the same 2-wire circuit that powers the strobes. So if we turn strobes on and there's horns in the building, we'll also be turning the horns on. Then there's speakers. I did list that separately because that is a separate circuit, and it has a couple other operations that are separate of strobes. Then we have door releases. I'm not going to get into access control. We've talked about possibly doing an access control and how fire alarm ties to access control doors, but also having the access side as one of these things. So I'm going to leave the access control doors for a separate discussion. For door releases, I'm more specifically focusing on the electromagnets, the door holders. Then we have elevator recall and HVAC shutdown. Both of those, I'm going to have slides where we break down into more details because there's different type of HVAC equipment that we tie into differently. And elevator recall, there's a bunch of different operations going on there. And then there's also a water flow bell. That one's probably the simplest one on this list behind strobes and horn strobes. But it does do its specific thing, so I'll mention it too. And I'm going to get into all these, I have like a slide for each separate one that we'll kind of go through. And then at the end, I have some troubleshooting tips to help you figure out, is it a programming problem? Is it a problem in the field? Do I have a bad device, bad wiring? So I have some quick troubleshooting tips that we'll go through at the very end of this. So the first thing we'll talk about is strobes and horn strobes. I also group door release with this because they're both activated at the same time. So the first point there I have, they can be general alarm or 3-floor type of evacuation. Again, just depending on what type of building it's in. If it's a high rise, you're going to see that 3-floor. That applies to the door release as well. Because if you've got a fire up on the 12th floor, we're not going to release the doors on the first floor. The first floor is not an alarm. We're just releasing the doors up on the floors that are in alarm because the door release has to do with smoke control and that sort of thing. And these are activated by any alarm. So whether it's an elevator lobby or just a common area smoke detector, any pull stations anywhere around, any kind of alarm, even water flows, are going to activate your strobes and horn strobes as well as release your doors. And then below that, the sprinkler water flow bell, that only activates underwater flows. Every building has to have at least one flow bell. If a water gong is used, that replaces a bell. A water gong and a flow bell are basically the same thing. A flow bell is activated by electricity. A water gong is activated by moving water. And so there's no electricity involved in a water gong, but it does the exact same thing. When water moves, it rings a bell. So if they use a water gong, we don't have to put a bell in. Most of the time they use a bell, not a water gong. So most of the time we're putting a bell in. If you have a high rise or a mid rise or something where you've got water flows on all the different floors, they're still going to have to ring a bell. In that case, we typically use something like a control relay or a dedicated NAC circuit that's programmed to only activate underwater flow. Otherwise, we'd be running auxiliary power up and down the riser to trip with each water flow, and that's not ideal. So moving on, then we have speaker circuits. These can also be general alarm or 3-floor. That'll kind of match up with your match up with your strobes. If you're using speakers, then you shouldn't be using horn strobes. Each building should have just one clear, distinct type of evacuation signal. Is it going to be a speaker ECS type of system, or is it going to be a horn type of system? That has to do with occupancy type and occupancy load levels. That's all determined on a code level, and then we put in what's required for that building. But because it's a separate circuit, it can be controlled separate, but it's still activated by any device going in alarm. If your strobes are going off, your speakers should be going off too. That's a pretty easy rule of thumb. But there's some times that you can use your speakers that you might not be using your strobes. Paging, for instance, if you do an all call, or you can select certain areas. So again, high-rise example, say you want to talk to the 1st through 5th floors, you select those floors. but you don't want to talk to anything above 5th floor, you don't select those. But if you want to talk to the entire building all at once, say, hey, we're about to have a fire drill or whatever, you hit the all call button and it pages the entire area. Speakers, we can also program different messages in. We can't do that with horns. Horns just make the one sound. But speakers, we can say, hey, there's a fire alarm. Hey, there's a carbon monoxide alarm. Or there's a tornado, shelter in place, active shooter, all sorts of things. And with these ECS systems, we can actually put in different types of devices that have special labeled buttons. We can have those custom made. So if they want a tornado warning system or something, we can give them a tornado warning button at like a receptionist desk or wherever they want it. So that's something else speakers can be used for. And if we're doing something like that, a lot of times we'll get a slightly different strobe than we use. It's still the system sensor strobe, still uses the same base, but instead of the word fire on there, it'll say alert. We don't deal with this a whole lot where we are. We did a job up in Oklahoma a while back that we had to put a tornado warning system in with the fire alarm. So that one was a little different, but for the most part, we don't deal with any of that, but it can do it. Then we have HVAC. If you don't know, HVAC is short for heating, ventilation, and air conditioning. So the first thing that I put in there is the air handler shutdown, because when you think about heating and air conditioning, those are your air handlers. These are usually shut down by the duct detector that we mount on the ductwork. And if you call it a duct detector to a mechanical guy and he's a smartass, he's probably going to tell you, yep, there's a duct, I can see it. It's a duct smoke detector, but nobody wants to say duct smoke detector, just duct detector. So just be aware, there are smartass mechanical guys out there that'll call you on it. But we have that housing we put in, and we put in the smoke detector inside of that housing, and it uses tubes that run through it, and it blows smoke across the smoke detector head. And in programming, we'll set those up to be supervisory signals, again, unless it's in Pearland. And then that supervisory smoke detector head will be programmed through mapping in the panel to shut down that unit through a relay. And that's typically the only way that happens is if that individual unit needs to be shut down. But there are some places where they want it shut down under general alarm. We don't recommend it. When people say that, we try to talk to them and be like, hey, we don't recommend it. This isn't good. Old code had it be that way. So sometimes you'll run across old schools or something where all the units are shut down under general alarm. But that causes all kind of mechanical problems for them in the long run. So we don't really want to do that. It screws up their compressors during like an annual inspection where we're triggering alarm after alarm after alarm and shutting the unit down time after time after time. It's really hard on the units, and it's not required by code. So we try to get them to let us set it up so that only the duct smoke detector on the unit will shut it down. The next thing I included under HVAC, helicopter fans. When these first started coming out and I started seeing them on job sites, I'd never heard them called helicopter fans. I only knew of the brand name Big Ass Fans. And so I was trying to figure out what to put in panels because I was pretty sure the end user didn't want us to say Big Ass Fan across their fire alarm display. So the technical term for them is helicopter fans. We just use a relay on these. We shut them down under general alarm. When we did the relay lesson, I talked about a couple ways to wire up where you have an addressable relay that can't handle high current circuits, and we can use an MR101 so that our addressable relay trips the MR101, which is a much stronger relay. It can handle the higher current. So sometimes on helicopter fans, you'll have to do something like that. Sometimes they actually have like some kind of VFD controller that has an alarm shutdown. When they have that, we can use just the addressable relay, and we don't have to use an addressable to power a stronger relay. But that's going to take some on-site coordination to figure out what type of fans, what type of controllers are they using on that job site. Then there's stair pressurization fans. These are another thing that's typically only seen in high rises. You might see them in like a mid-rise or something. I'm not sure. I know for a fact they're in high rises. The point of them is they pressurize the stairwells with extra air, so that whenever smoke is spreading on a floor, it's going to hit that higher air pressure in that stairwell, and that higher air pressure is going to push the smoke back away. That way, as people are evacuating in the stairwell to safety, they're not going to get choked up by smoke, or their vision's not going to get impeded by smoke, anything like that. Instead, it's going to be forcing all this fresh air into the stairwell. So in order for that to happen, there's fans on there that we have relays, and we actually turn the fans on when the alarm happens. So it's kind of like the opposite of air handler shutdown. We're actually turning the fan on whenever an alarm happens. That way, hey, there's an alarm in the building, smoke was detected somewhere. We're going to make sure it doesn't get in the stairwells. And then there's that same duct detector housing with a smoke detector installed on the ductwork for that fan blowing into the stairwell. And it's still a supervisory signal, and it's watching to make sure that fan doesn't start pushing smoke into the stairwell. If the fan starts pushing smoke into the stairwell, it'll shut it back down. So as far as physical installation goes, it looks the same as a regular air handler unit, but as far as operation goes, it almost operates in reverse until smoke is blowing through that ductwork, and then it shuts it back down. Then the last thing is dampers. This is another really common one, and it's very similar to the helicopter fans. Depending on how much current is used on the circuit, you might have to use that MR101 with an addressable relay. And so that's just going to take some on-site coordination with the electrician. Hey, how much current's getting pulled on this circuit? And then looking at the cut sheets in the submittal for, hey, how much current can this relay handle? And then, you know, telling your project manager or contacting Terrence or whoever to let them know if you need a MR101 or if just the addressable relay will be fine. Then we have elevator recall. I'll try to explain this one pretty concisely and straightforward. Mike's talked about wanting to do a whole week where we just talk about elevator recall. So we'll see how that goes. Because we'll probably end up doing that at some point. So first of all, elevator recall is only activated by smoke detectors in the elevator lobbies, elevator shaft, or elevator machine rooms. I've been in some older buildings where any device on the first floor would activate alternate recall. That's not current code anymore. If an old building works that way, then it can be grandfathered in and we don't have to make them change it. But that's not how we put in new systems. So I'll start with each of the 4 outputs we do, starting with primary recall. Primary recall, that's going to send the elevator car to the primary level of discharge. Here in our super flat, no elevation at all world that we live in Houston, that's pretty much always the first floor. That's the main floor people come in and out of. That's your primary level of discharge. Every single elevator lobby smoke detector in the building, except for the one on your primary floor, will activate primary recall. So if you have a basement will activate primary recall unless the basement is the primary level of discharge, which that would be weird. So basement and then second floor up all activate primary. The alternate is if there is smoke detected on your primary level of discharge, specifically in the elevator lobby, it's going to send it to an alternate level of discharge. For us, this is usually the second floor. In places with elevation changes, it kind of depends on how the building sits against the hill, because if there's no direct discharge from the second floor, but there might be from the third floor, it could actually recall it up to the third floor if it's on like a real steep hill or something. The only one that activates this is any alarms that happen on your primary level. So if your machine room is on your first floor and your first floor is your primary level, then when your machine room goes off, it's going to send it to the alternate level. Your primary elevator lobby, your first floor elevator lobby is always going to send it to your alternate level. If you have your elevator machine room on a different floor than your primary level, then the machine room will still send it to your primary. I hope that's not too confusing. I'm going to go ahead and move on to cab hat, because I think if I talk anymore, I'm going to make it more confusing. Your cab hat, if you're in an elevator car and you look at all the little circles and lights that are there for your buttons, one of them looks like a firefighter's hat, and it'll light up. Well, if it's lit up, you probably shouldn't be in the elevator car. But that's all. It's a light with that firefighter's hat in it, and that's to communicate to the emergency responders that smoke or heat or fire or whatever has been detected in either the elevator shaft or the elevator machine room. It's communicating, hey, this elevator is not safe to use because there's fire around its control equipment or around the elevator itself. That does not light up for any of the elevator lobby smokes. It only lights up for the machine room and for the elevator shafts. And it'll light up for heat detectors and smoke detectors alike. And again, depending on where it is, it can also trigger alternate or primary, because like your top of your elevator shaft, that's going to want to send your car down to your primary level. But if your machine room is on your first floor, then it's going to need to send it to the alternate level. So a lot of time, this is one of those things where we got to coordinate with the elevator guys so that we figure out what kind of signal they want, because sometimes they want a cab hat with a primary or a cab hat with an alternate. Other times they want two separate cab hats, one that'll be a cab hat primary combo and one that'll be a cab hat alternate combo. And those combo ones will be separate of your regular primary and alternate. So that's just a question that varies on which elevator manufacturer is on that job. And then the last one is a shunt trip. This is pulling power away from the device, because these elevators are powered by 480 volts. So we want to pull power off of it before water hits it, because water and 480 volts don't mix very well at all. So the only thing that activates shunt trip is heat detectors that are either in the elevator shaft or heat detectors that are in the elevator machine room. If you don't have sprinkler heads at the top of the elevator shaft and you don't have sprinkler heads in the machine room, then you're not going to have shunt trip. And when you're installing your heat detectors, they need to be installed within 2 feet of that sprinkler head. And that's because our rate of rise heat detectors that we put in, they activate faster than the sprinkler head will go off. So it's kind of like an early detection of, hey, this sprinkler head's about to go off. Let's kill power to the unit so that power can be gone before the sprinkler head goes off. Then the sprinkler head lets the water out and the unit's already powered down. And so that saves at least one problem for the building owner and as far as the spread of fire goes. In City of Houston specifically, if you do have shunt trip, they require a delay on it that allows the elevator car to go all the way to wherever it's recalling to, whether it's primary or alternate. It'll go to that floor and then open the doors. And once the doors open, then they want the shunt to happen, because they don't want it to lose power like halfway between floors with people in the car. Outside of the City of Houston, all the elevator inspectors, all the fire marshals, they all want it to shunt trip immediately. But inside the city, they want that delay to happen so it goes to wherever it is and then opens. Most of the time, a 30-second delay works great for it, so you just set it to 30 seconds and don't worry about it. If you're in a taller building like a mid-rise or high-rise, you might have to add some time to that. 45 seconds usually works pretty good for most buildings that are taller. But if it's really tall, of course, it's going to have to be longer, because it's just how long does it take that elevator to get there and open up. But 30 seconds most of the time is going to be all you need. All right, so that's all of our different kind of input, output, relationship understanding kind of thing, our sequence of operations. I'm going to move on to troubleshooting, and then I'll open up for some questions if y'all have any questions. All right, for troubleshooting methods, first, go to whatever is giving you your problem. Let's say you have a relay that it's checking in at the panel, you don't have any troubles on it, but whenever you activate whatever input it is that's supposed to then activate that output, and then nothing's happening, these are kind of the steps to do that. First, you're going to go to wherever that device is that's not doing its job properly, and use your meter. Make sure you have the right power coming there, or the right SLC signal, whatever the case is. Make sure everything is correctly coming to it. And then also check the device address. I mean, I know I said that there's not like a trouble on the panel in this case, but maybe it's not programmed in or something, or maybe it's checking in as something different. So just make sure you've got the right device address on it. And then lastly, if a device is not causing a trouble condition, but it also isn't working correctly, then take that device and take another same device type. So say I said we have a relay that's not changing state when it's supposed to. Find another addressable relay that is doing its job correctly and swap the two relays, swap both their addresses and their locations, and then test it again. And then down here I have two different points. If the device still doesn't function, even though you've changed its physical location, you've changed its address to a spot where you know everything was working before, then that means you've got a bad device. So if that device functions correctly, but the device you just moved over to the other place now isn't functioning, and so it's the address is what the problem is, then it's a programming problem. It might not be mapped correctly, or something weird going on. So that's when you call your programmer. This can save you some time on job, some headache, because we don't have as many programmers as we have techs. So you might have to end up waiting, and you're trying to get something done and you're under the gun and you need it to happen now. These are some steps you can do to kind of save yourself some headache and some hair pulling, and kind of keep your job moving, keep it progressing and all that. Other than that, we've talked about all the other ways to troubleshoot with a meter, to make sure your SLC is active at the right place, to make sure your power is where it's supposed to be. So I'm not going to dig into that again, but I will open up for questions if anyone has any questions about inputs, outputs, sequence of operations, or this troubleshooting. Floor is open.
Okay, here we go.
All right, Ramsey, what you got?
On the devices for the elevators, like the smoke detector, I know you were saying that the heat detector has to be within 2 feet of the sprinkler head.
Mm-hmm.
Okay, now for the location, as far as the lobby smokes, how far do they need to be to the elevator? Or how far away can you go away from the elevator?
Okay, that's a really good question. So all smoke detectors for any application, not just elevator specific, have to be within 21 feet of all points of everything. So that's the furthest that any smoke detector is listed to be placed from. So just by that standard, it has to be within 21 feet of the door. By elevator inspectors that I've had give us problems with it, they want it within 10 feet of the door. And so I think that's written somewhere in their elevator code that they want it within 10 feet.
All right. Yeah, I know you said you was gonna get into that a little bit later, have another session on that.
Yeah.
That's all right.
All right. Well, it's 12:30. If no one has any other questions, thank you for being here. Y'all are free to go. See you same time next week, I guess.